Second set, starting with column 1, we're given side, side, angle, and that's enough information to use the sine law. Step 1. When you're given labels, try to stick with the same labels. If you don't have any in the picture, you can certainly decide on any letters yourself. And we'll go A, B, C. First step, it's always good practice to solve for the largest angle first in the picture. The largest angle corresponds with the longest side. Sine of C over side length C is equal to sine of B, given, over side length B. We always want to put our unknown measurement on the top left. It's just easier to solve the proportion. Sine of C over side length C, which is the 11, is equal to sine of 22 degrees over side length 5, which is little b. Sine of C is equal to 11 times sine of 22 degrees over 5. That means that the angle measure is going to be the inverse sine of all of the above. 11 times sine 22 equals, divide by 5, and now take the inverse of that, and we get 55.5 degrees. Before moving on, think about that angle measure. The calculator gave us 55.5, but our picture given does not correspond with that. Ooh, I lost the 55.5. Well, I'll plug it in again just to show you another way. Inverse sine, if you do it all at once, you need double brackets. 11 times sine of 22, close a bracket, then divide by 5, and close the other bracket. Press enter. There's the 55. When you get a situation like this from a picture and you know it looks off, you're dealing with something called the ambiguous case, and we'll have a look at it in the third set, but I don't quite want to go there yet. If we're at 55.5 degrees for angle C, just trust me in using not 55.5, but use 180 subtract 55.5. The angle is 124.5 that we're going to use. We won't use that one. We'll use 124.5 degrees for angle C. And don't worry, I'll show you why that happens in the third set of examples. Step 2, we'll figure out angle A. It's 180 degrees, subtract 22 degrees, subtract 124.5 degrees, and we get 180 subtract 22 subtract 124.5. 33.5 degrees for angle A. So far we have angle C is 124.5 degrees. Angle A is 33.5 degrees. Step 3, find side length A. A over sine of A is equal to B over sine of B. A over sine of 33.5 degrees is equal to B, 5, over sine of B, 22. A is equal to 5 times sine of 33.5 degrees over sine of 22. 5 times sine 33.5 equals, divided by sine 22, 7.36. A is 7.4, right there. Now, does that all make sense? We have angle 22 degrees corresponding with 5. The largest angle corresponds with 11, and 33 corresponds with 7.4. That seems about right. Versus in the second set, second column, we're going to be using the cosine law. Because we're given 3 side lengths, we need to find the 3 other angles, and the only way to do that is using the cosine law. Our cosine law is written like this, but if we're looking for the angle here, we need to solve for this part. So we're going to subtract b squared, subtract c squared. We have a squared minus b squared minus c squared is equal to negative 2bc cosine of a, and then we'll divide by negative 2bc, both sides. Negative 2bc makes 1, and we've got our cosine alone. We'll just put it over here. And on the other side is a squared minus b squared minus c squared all over negative 2b times c. When we plug in the values, it doesn't matter as long as we're consistent here. We're going to look for cosine a, so we will put our a squared minus b squared, there's a, little b, little c, 7 squared minus 9 squared minus 10 squared all over negative 2 times 9 times 10. Cosine of a is 7 squared minus 9 squared minus 10 squared equals, divided by, and I'll just put it all in brackets on the bottom, negative 2 times 9 times 10, close my bracket, equals, and then I need to do the inverse. I'll go second function cosine of that ratio, and the angle is 42.8 degrees. Cosine of all of that. I think I'll show you that that's the inverse of all of that to get the angle. That is 42.8 degrees right there. Now we can use the sine law for the other ones. I'll just make some room up here. That was step 1. Step 2, we'll find out angle B. Sine of B divided by side length B, which is 9, is equal to sine of A, we'll put 42.8 degrees, over side length A, 7. Sine of B is 9 times sine 42.8 degrees over 7. Keep that 42.8 in your calculator and go sine of 42.8 equals times 9 equals divided by 7, and then we'll do the inverse sine of that value equals 60.9 degrees. B is 60.9 degrees. 60.9 degrees for B. Almost there. Now we just need to do step 3. We'll squish it in here. Step 3, third angle C is, we're not sure. It's going to be 180 degrees, subtract 42.8 degrees, subtract 60.9 degrees. Almost out of room. Maybe I'll box it off. And that'll give us 180 subtract 42.8, subtract, grab our 60.9, equals 76.3. degrees. 76.3 degrees for C. We have all three sides and all three angles. That was a large set, and it definitely posed some question marks here when we were using the sine law.